Hello guys, so I think I'm audible. Hello Aditya Kumar, hello Bhuvaneshwari, hello Harish, hello everyone. So how are you guys doing? Hello, am I audible? Anyone in the chat? So how are you guys doing? Yeah, I think I'm audible. Yes. So how are everyone? How are you guys doing? So it's the end of the Jan, right? So how did the first month of the year go? Uh, any, yes, okay, fine. Yes, Bhuvaneshwari is like, yeah. Okay, thank you guys. Yes, yes. So, how did this month go? So, 2025 has started and the first month is almost coming to an end. So, we are in the last week of Jan. So, how is this year going for you guys? So, we can just start with some chill questions and then we'll go on to the main content for today. Yeah, so Aditya Kumar is like, start live fast, eagerly waiting for this video. Yeah, yeah, sure, definitely. I can see the eagerness. Yes, today is a important topic we are going to talk about. Bhuvaneshwari is like so far so good. Aditya Kumar is fine. What about you? Yeah, I'm fine. I'm doing great. By the way, Sijin is traveling and I won't think he'd be able to join the live. He might be in the chat section helping for you guys, but let's see. It would be mostly me only, but I'll be talking about both technical side and all the mini project ideas that we're gonna do. I'm audible, not too good. Not too good means is the audio quality or what are you trying to say, Aditya? I hope the audio quality is good only. Mostly me only, but I'll be talking. Yeah, it's great. Yes. Starting is bad. Talking about the year. Don't worry, man. You still have 11 more months. We can just crack it out. Yes, you can just give an introduction about yourself. I think this is the first time I am seeing your name or face here. So it would be great if you can say some things about you. So we can talk about what you want, where you want to go, all the other things. And if other people, if you guys have any doubts, you can just start posting questions, and I'm obviously there to answer them out. Yeah, Bhuvaneshwari's fire reaction. Yes, sure. Obviously, it's great. Uh, so today we are going to talk about mini projects. So like a lot of students have been asking this topic, so we would like to get some ideas on mini projects, topics, and all. And in the end, I'll be showing a tool also, which can be useful for you to work on your mini projects, get all the resources. It's like all in one place kind of a thing. So I'll start with the small mind map. I'll just show what are the different technologies that are being used in biomedical and what and all you go through in your college, what skills you learn, like what different concepts or topics are being taught and what kind of projects can be extended to that side. And later on, I have made a list. So it was in a hurry only because I was able to do a few hours before the live. So I've made a list of a few projects and some extensions too also. So it will be standard projects. And I'll be also talking about some novelties or extensions you can make so that it becomes a new project. And if you guys are interested, I will talk about, I have already spoke about the research. And if you want, I can talk about research once again, like research papers, how to extend your projects to research paper, all the other things. And finally, we'll end with this tool that I'm going to show, which will be helpful for your projects if you're a starter. So this is what I've planned for today's live. So we'll just wait for a few moments, and if more people join, then we'll start with this. So Aditya Kumar is like, nope, I always join, but I'm here for many projects. Okay, fine. So it was like I'm seeing this name commenting a lot in this only. So I think you're more eager for the mini projects. Yeah, that is what we are going to cover today. So please share this live with your friends, classmates, colleagues, and all because I'm going to talk a lot about mini projects. I hope that many people are in the second or third year, I guess, and are looking forward to work on mini projects to boost their resume or for college purposes, research purposes. There are a lot of other things. So this is definitely going to be an interesting topic, and it would be good if you can just share this link to your friends and make them join also. Yeah, so Aditya is like, yeah. Don't worry, today you will have an interesting session only because I'm going to talk about majorly I've collected projects on IoT, electronics, signal processing, and image processing. So some I have listed and some I'll be talking about because I don't prefer of writing much. I like to talk more. So at the end, once the list is over, I'll be talking some of my own projects also, some of the other things which you can extend also. So this is what I've planned for today's life. So let's see how this goes. Any questions, guys? Any questions you want me to answer before starting the live? I would like to answer some questions because what happens is once I start sharing the screen, I might not able to see the chat, and you guys start posting there, then I might not be able to reply them immediately. So that's why I'm waiting for a few minutes, maybe 5 or 10 minutes. If you guys have questions, some general questions regarding biomedical or AI engineering, roadmap planning, blah blah, whatever it is, you can just ask right now, and I'll answer it. If not, we'll wait for 5 minutes and then I'll just jump onto the topic today. I'm interested to assist you in your project. Okay, Aditya Kumar. So you can just message me later. You can like it would be nice to have a collaboration. So just say what skills you know because you might know about me. I'm working on AI, machine learning, deep learning, image processing. So these are my majority areas of interest. So if you're looking forward to work in that, then definitely I can assist you. But as of now, I'm not working in any current project. If you have some ideas, I can help you, I can mentor you. So yes, the community is always there. You can just form a team within yourselves, and I can mentor you to complete or finish a project in one or the other way. It can be helpful for you. Harish is like, how has Jan been for you, bro? It's really boring, man. It's great. So actually, my main project for which I've come here, that is almost over. It's almost to an end, and I don't have much work to do. So that's why I'm focusing on the YouTube, so releasing a lot of videos, shorts, and all the other things. So this is how Jan has been for me. It's a kind of bit boring only, but hopefully the rest months would compensate for this, and I'll be looking forward to some interesting things coming up. So yeah, regarding this project also, so we have some plans. I wanted to say that. So we are planning. Me and Sijin, we are still planning. We're not sure when we're going to execute and how we're going to execute. But since a lot of people are interested in project assistance, we are thinking of starting a service like that. So what we are thinking is, you generally would know the project centers, right, that are available. So where you can go and buy the project directly. But we are not interested in that. So if you want to, why do you do engineering when you want to buy your own project? So instead, what we were thinking is we will be doing project assistance kind of thing. So where instead of you just buying the project, we will teach you the project. So if you say you have your own idea, so let's say, sir, I want to develop a patient monitoring system and I want to use AI to track the data and I want to do alert system, some kind of thing. So instead of us making the project and giving to you, we will give you the components and we will teach you how to do the project so that you and your team will learn that also as a skill. Instead of just buying the project, you can just buy the project and use it for the sake of completing your degree. But what's the use? You won't have a skill, and it will be difficult for you in the later process to sit in interview or to go for further studies, etc. So that's why what we were thinking is we would be teaching you the concept and we will be helping you in assisting you the project. So this is a bland idea we have. We still have to work more on this. It would be great if you can give your suggestions on this because I feel a lot of project centers just throw away the topics and you just buy them the entire project and you just they give you the PPT, they give you the paper, whatever things you want, they give everything for you. You just go and show in front of your staffs. That doesn't make any sense, right? Then what is the use for doing a project when you buy it fully? So we have some ideas. This is what we are planning. So I have a list of projects that I have already done. And if any people are interested to learn by doing projects, you can definitely approach me and Sijin. So we can do a one-on-one mentoring session where we can help you towards a specific projects. For example, if you want to do one particular project, you can come up with the titles or we will give you titles. So for example, if you're interested in image processing only, then I will give you a specific title to where from start with. So you can start by doing projects, you can learn. So obviously I'm going to drop videos in the YouTube channel. A lot more are going to come. So you'll be learning the theory part. But if you like avail these services, it will be a one-on-one counseling or mentoring session where I will be mentoring you towards a particular project. So once you finish this project, then I'll recommend you which project you should do next. So as you complete projects, your practical experience will also boost, and you can add those projects in your resume, LinkedIn, GitHub, blah blah, wherever places you want. So Harish is like, the short video was very good. Looking forward to more like this. Yes, so as I said, I have a bit of free time. So I would like to do a lot of videos like this. The thing is, this is how I learned AI. So I used to correlate with analogies in real life examples, and that's how I was able to remember a lot of concepts. So now also I'm planning. So it's not that much easy because I only have few of these analogies with me, but I have to sit and think a lot more. I have made some shots and I've kept it, so I'll be releasing maybe once per week, something like that. So, any doubts, guys? Any questions? Or if not, I'll just start with the video. And I would like to get your suggestion on this, which I said right now, the project assistance or project mentorship that we are trying to plan. We are still yet in the planning phase. That's why we thought let us show it to the community and ask feedback from them. So if you guys like this, just drop some comments or say whatever your suggestions are, and we will take forward this accordingly. Anything else? Or else I'll just start with the session today. Okay, I feel I'll just start with the session. Like it was enough of introduction. I've said a lot of things. So I'll just change my cam and I'll just come back in a minute. Yeah, so guys, am I now visible? So now, yeah, I hope I'm visible. Yes, yes, yes. So Aditya Kumar is like, we'll be happy if you assist us in your minor, and yeah, that's the main idea what I'm trying to say. So this is what we want to do here. So I'll start the session. So what I'm going to do in this part is I'll just make a small mind map, and I'll be showing the different technologies or how different concepts or topics are present in biomedical and how you can do projects. So okay, so we'll start with the different projects that we're going to do, and it can be basically of two types: hardware. I'm just new to this tool, I think. Yeah, so it can be hardware, and the another type can be, okay, I think, yeah, I'll just go in this way. Yeah, so it can be hardware, and the second type can be software, and the third type can be hardware plus software. So I hope this is clear right now. I'm also new to this tool, mind maps and all. Yeah, so it's clear. So in hardware, we can go with IoT obviously. So IoT refers to Internet of Things, where we have Raspberry Pi, we have Arduino, we have Jetson Nano, we have a lot more other boards. Even NVIDIA is coming up with their own boards. So you can use these boards to do automation kind of projects. So basically, our idea is to go for automation. So you can integrate AI in these boards also. And another thing which we can go is obviously the hardcore electronics, where you design your own boards. So where you design custom electronics equipments. So using the resistors, transistors, amplifiers. I read electronics maybe 4 or 5 years ago. I'm not that much well versed in electronics, but you can definitely develop your own electronics boards, projects, and all. So in electronics, I would suggest once again. So first, you can definitely go for PCB designing. So printed circuit boards designing, where you can design your own things. So there are a bunch of softwares that are there that you can use it. And in the other hand, you can go for online projects. So online boards. And the great tool that I would suggest for this is Multisim. So Multisim, NI Multisim, I guess National Instruments is the company that has developed this software called Multisim. So in multisim, you can create this one circuits, digital circuits, I mean analog and digital, both of them in an online fashion. So let's go to multisim. Yeah, you can see Multisim has this online circuit simulator. So there are a lot of components, whatever electronic components you have studied in your first and second year, right? So right from the resistors, capacitors, inductors, transistors, I guess sensors are also there, analog, digital. So all the other ICs, whatever things you see, this all will be available here. So you can just check a tutorial. So you can see here. So we have the power supply, so we have the voltage supply, current supply, all the other things, whatever components you have just studied, right? The same is available in an online version. So you can go for this, and you can, so there is an app also available, desktop application is available, and online is also available. And one of the cool features that I've observed is you can do something called as publish. So you just once you have developed a circuit or something, then you can just publish it in online, because the Multisim Live has its own online community. So in that community, you can showcase your projects. You can create a profile also. So you can see the simulation results, you can save your projects, you can upload those projects in all the other places. This is what I'm trying to say here. Collaborate with the community. So this feature is what is an interesting, and it is most a good feature that I like about Multisim. So you can collaborate with the community. The Multisim has its own online community. So once you have created a circuit, so let's say you are creating an LC oscillator or an RC oscillator. So once you have done that, then you can publish that circuit and put it in your community. So you will be having your own multisim profile. So you'll be having a link of your own, and you can show it in your resume also. So if you're a hardcore electronics guy and you want to build your profile in electronics, then you can start with multisim. You can build small projects, and once you develop the circuits, you just publish them. Write a small, give attach a small write up to it also. Just don't blindly publish the circuit. So instead, in accordance to that, you also write what the circuit is about, what are the different components, and this kind of a tutorial. So what you see here, right, this can also be great. So you can take screenshots of each phase. So first you just say you put the power supply, step one. Step two, you add two resistors. Step three, you add two capacitors. Step four, you add this, that. So you do some calculations also, because the frequency that is generating, I think it is 1 by 2 pi RC, if I'm not wrong. So you need to find the resistance and capacitance value, and you have to calculate accordingly to generate the frequency signal, right? So then you have to do some calculations. You can post the math also. So all the other things, if you make a good tutorial along with the circuit, and you can just post it online, you can be a part of the groups, community, and all the other things. So ultimately you will get a link of your own. So if I am registering here and I am publishing my circuits, so in my name Sairam Aditya, there will be the circuits that I have published. And finally, you can get a link of your own, which you will be showcasing to the outer world wherever you want. So these are all the things. That's what I've said in the end. Add circuits to your group. So select a circuit from my circuits and click on the share button. So you can join to other groups also, and all the other things. So this is a tool that I used when I was doing my bachelor's in during lockdown, because second and third year were the most important years, and that got hit by lockdown, and we were staying at home only. So at that time we used to do a lot of projects in multisim. I even used to create a group of multisim with my student classmates and all. We used to do these things with juniors and all. So we did a lot of things. So you can also start something like this, and this will be really great. So if you're a starter and you don't have much idea of electronics and you want to go somewhere to start with, then I would suggest here, because if you don't have much idea, then without having that idea and directly buying the hardware and doing the stuff won't be that much recommended. This is free, obviously. You don't need to pay anything. It is nothing for you. So you can just install this software, or you can just go online and you can start creating circuits and all the other things. And once you feel confident, then you start buying the hardware components and go for a hardware design. So in a proper manner. So this is the first thing I wanted to show you, multisim. So this is what I've mentioned in online boards multisim. And yeah, so what we have is before, so first step is you go for the online boards, that is the different websites that are present, or software tools that you can use to design the circuits. Once that is done, then you can go for breadboard. So I obviously think people would be knowing what breadboard is right now. I don't have anything with me, or else I'd have shown what a breadboard is. So this is the breadboards are like it's a temporary detachable kind of a thing. So PCB is permanent. So once you solder the pins or wires, then you can't reuse them. But breadboard is detachable kind of thing. So you can go with the breadboard things. So once you are pretty confident with this, and next you can go for breadboards where you can develop basic circuits, whichever circuits you have done in the online multisim, right? The same circuits you can just carry out in breadboard. And once you're done with that, then you can go for PCB. So you need to do soldering also there. So you need to so the same circuit which you developed in breadboard, you will be doing it. Maybe I'll just drag this. Yeah. So I think now it would be visible. Yes. So you need to do the soldering, and from the soldering, you will be able to design a permanent board. So this is about the evolution of electronics, how you can start your projects on. So you guys have any doubts up till now? So you want to ask me anything? If you guys already know multisim, have you seen this? And even for PCB also there is one online tool. I guess it's Autodesk. I'm not sure. I used these long back. So before you design the PCB board, you have to do an online configuration. I think it's in Eagle Autodesk or something. I'm not sure. I just yeah, it's Eagle. Yes. Autodesk Eagle, yeah. So this is what I was saying. So this is a software that they use to design the PCB boards in an online in the software. And once after that, you can just give it to the local printer. They will punch the holes and give it to you. And after that, you can insert all the components, do the soldering, and you will have your own hardware board ready with you. So this is about Eagle Autodesk. So these were some of the softwares that we used when I was studying. I'm not sure what is the NVIDIA board that you told, bro? I thought, oh, they made only GPU. So recently, Jensen Huang has said that he is developing. I think he has developed. It's in US only. I'm not sure if it's in India. So the AI boards, they are developing hardware AI boards where you can directly plug in your HDMI, USB cables or whatever things you want, and you can use them as supercomputers. So it's small size computers. Yeah, so it's something like this. So you can see here. So it will be like a server in a hand. So instead of buying a big system, buying big CPUs, GPUs, all the other things, you can use this for small scale projects. So these are the things that I just read the news. I'm not sure. I have not delved deep into these things, but they are developing their own AI boards kind of thing. So in that you can apply AI operations and all the other things. And they are also developing GPUs, CPUs is what they do the most, or not CPUs. GPUs is what they work on the most, data centers, all the other things. But now they are starting to come into IoT and automation where they develop the pre-trained algorithms. So I have seen an NVIDIA pen drive or pen stick. In that, there are thousands or 2000s of different algorithms, real-time algorithms that are being used. So you don't need to train your hardware or train your own algorithm and use it in the hardware. Instead, you can use this directly and the models can be accessed directly and the algorithms can be used in the hardware where you can do the integration projects directly. So these are also some things that they're working on. I just saw recent news from NVIDIA that they are working on this kind of boards where they are trying to equate to the power of a normal laptop in a very less cost. And you can use some small and medium scale automation projects. So for that, the GPU, RAM, and all the hardware power you can access from this kind of devices in a very small price. So this was about electronics, some of the things I know, where you start with the online boards in multisim and then later you go with breadboards, the temporary circuits. And once you're done with it, then you can go for permanent circuits using PCB. So first you go to the online software and you design it. And after that, you can give it to a local shop where they print, punch the holes and you can insert the components, do the soldering and your permanent circuit is ready. So any doubt? Any queries you have guys till now regarding electronics? Please don't ask much. I don't have much idea, in-depth idea about electronics. If not, I'll go into the next. So these are not that good areas of mine, but later once we go into software, AI, so in that time I'll be able to say a lot of things in depth. Okay, fine. So I assume there isn't much of doubts here. So next we'll go with IoT based projects. So IoT, obviously you have the different boards, you have Arduino. This is what they start with because it's cheap, it's a low cost. And then you have a Raspberry Pi, which is a bit costly. And then you have Jetson Nano, it's another board. And you have NVIDIA boards also. So there are a lot of different boards that are coming up. In Arduino also you have Uno, Nano. So the size is reduced, right? Nano is very small, Uno is a bit big like that. Harish, like, does embedded systems come under electronics pro? Yes, so embedded systems is basically the hardware based software that I was trying to say. So where you will be trying to program the hardware to do specific functions. So that also comes under electronics. But I've kept in a different category because I'm classifying it based on the deployment. So hardware deployment means proper hardware. Software means in a laptop you write the code and do things. And hybrid is combination of both. Embedded systems do come under electronics because electronics is a very uh, major branch, right? So it's a vast branch. So inside that, a small portion is embedded systems. So in IoT automation, so that I was saying, Arduino, Raspberry Pi, Jetson Nano, there are many more other boards. And from these boards, what you can do is basically you just insert a lot of sensors. So regarding biomedical fields, what are the different sensors that we have? So we have body temperature, and then we have we can take SpO2. So SpO2 is nothing but the saturated oxygen, blood oxygen level. And so this SpO2 was very important during the COVID time, right? Because patients who were having COVID had a drastic change in the SpO2. And then what else we have? So we can take EEG, and we can take ECG, and we can take EMG, EOG, ERG. So EMG is for the muscles, ECG is for the chest, EEG is for the brain, and EOG is. So can someone say what's EOG and ERG in the comments? EOG and ERG are something not that much common. So can someone say what EOG and ERG refers to? Okay, so I'll just be waiting in the comments for that. So these are the different sensors. There are many more sensors. So we have pressure sensors, and we have this one, heart rate. So we have, yes, yes, Harish, you're right. Electroaculograph. And ERG, it is also kind of related to EOG only. So these are the different sensors that you can use. I have just mentioned a small list. Um, Yes. So you can what you can do is you will be connecting these sensors. ERG refers to electroretinogram. So it is taking the picking up signals from the retina of the eye. So that will be mostly useful for muscle eye management, coordination, how the eye coordinates with the muscle, and you can diagnose some eye-based diseases also. So these are some in specific advanced sensors, but there is always basic sensors that you can use. So you have blood pressure also, you have pulse, you have SpO2, body temperature. So there are a big list of sensors which are very cheap and affordable. So take them and you just attach them to the sensor, the hardware devices, that is the IoT devices, basically Jetson Nano, Raspberry Pi, Arduino, and you can collect the data from them and you can do some analysis. So this is about IoT based projects. So you can do data collection. So what kind of projects and all you can do is you can go for data collection and analysis, where this will be a hybrid software hardware mix. Another thing you can do is monitoring and some kind of alert systems, so alert systems and all the other things you can go for. And then you can go for some controlling. So if you want to control something, so control. For example, let's say you are trying to provide oxygen to a patient, but there is a specific level. So let's say we are taking the SpO2 reading from a patient and you observe that it is less. So what you will be doing, you will try to provide oxygen externally, and you have to cut off a limit. So once you start providing oxygen, then he will be respiring and his SpO2 level will increase. So there is a normal range. I guess below 90 is somewhat in the danger region, and where you give this artificial oxygen. So once you give the oxygen or you give a nebulizer instead, so where you give the medicine. So let's say the airways are clogged for the patient, and once you give the proper medicine in a nebulizer in a continuous fashion, then the airway will get cleared and the patient will be respiring normally, and the SpO2 will increase. And it will be going up to a level, let's say 92, 93, 94, 95, 96. So 96 or 97 is in the normal range. So beyond that, the patient might not need the nebulizer. But if you give it more and more again, then it won't. It is a waste of cost, right? So you can maybe control this in an IoT or automated fashion. So once you um, keep track of the SpO2, and once it is above the threshold, you automatically cut off the medicine supply. So this kind of a thing. So this will be reducing the nurse visit to the patients. So if it is a big hospital and it's an emergency situation where a lot of nurses are very busy and they're quite occupied, so you can develop these kind of automated systems which will be taking care of the patient, and the nurses need not frequently go and visit the patient, so they can just supervise. So all of these IoT systems can be supervised with a main computer. So in that computer you just sit and supervise what and all are doing. So kind of an administration system which you can develop, which will help the nurse visits, lessening the visits to the patients. So I just brought this up idea right now. So you can do this kind of controlling, cutting off the supply, cutting off the valves, or doing the other things. So if a patient is being exposed to some kind of electrical therapy, and if the ground is not connected properly, so he might get shocked. So in that case, if you feel that there is some kind of anomalies or abnormalities, then automatically cut off the power supply. So all these things can be done using IoT projects. So you just write simple codes. It's not even AI, it's not even complex software coding you're going to do. Just simple if else conditions with threshold values. And if it goes beyond that, then you take some decision or an action to cut off or some other things. So these are the different hardware ideas that I would suggest for you guys if you're looking to do some projects and all the other things. Mini projects or even major projects. Major project means you have to go for a big scale. Mini project means you can start with a very simple thing also. So out of these sensors, you can just pick up one sensor or two, three sensors, connect them together, develop a patient monitoring system, collect the data, analyze them. So this is a mini project. And if you want to do an alert and you want to do AI analysis, so it's a bigger project. So in that case, you can extend it for a major project. So this is all about hardware, electronics, IoT, all the things that I've said. So if you have any doubts regarding the hardware component, hardware side, you can ask right now. I'll be explaining, or else we'll just go into the software. So the part which I know the best. So I feel a bit comfortable and confident I can explain a lot more things there. So any doubts, guys? Do you have any queries? Is this clear? So because it's been a long since I learned electronics and my electronics side is not that strong. I hope I have said all the things properly only. Okay, if not, then we will go to the next part, that is software. Yes. Yeah. Okay. Thank you, Harish. So software. So let's start with this. So software, obviously, we will be going based on the data. So first is signal processing. And in signal processing, once again, what kind of signals do you collect from the body? Uh, Once again, you have ECG, and then you have EEG, you have EMG, you have EOG. I'll just write them together, EOG, ERG. And other things you can do is PCG. What is PCG? If someone in the chat, can you just say what is PCG? And what other signals are present? As of now, I'm able to recollect these only. So what we will be doing is we will be collecting. So that is where the hardware part will come. So once you develop an EEG system and you're trying to collect EEG from the patient, now you will be developing a software to do some kind of analysis. And the first step you need to do is cleaning, which we technically call as pre-processing. So cleaning or pre-processing is one of the vital steps that you need to do, because the signal that you obtain will not be proper or clean always. So what issues can be there? So we will be definitely having noise. So noise is one of the important issues, and it is one of the things that you can observe in real-time data, because there are different reasons for the noise to occur. So that is a separate topic itself. If you guys would have learned about digital signal processing or signals and systems, then you would have known about these things: noise, white noise, black noise, salt and pepper noise, Gaussian noise. So there are a lot of kinds of noise. So noise can be in the time domain and it can be in the frequency domain. So sometimes the most one of the important noises that we observe is called artifacts. So artifacts is nothing but when the patient moves. So like when we am performing the EEG and the patient moves or he shakes his head, then there will be a small change in the signal and you will get some erroneous values. So that's called artifacts. So what we should do, the most important step we will be doing is filtering. So we will be filtering and removing the noise from the signal, because noise is an unwanted component that is present in the signal. So what kind of filters can we use? So that depends on the type of noise. So I guess in electronics, you guys would have studied about the four filters. So it's nothing but low pass filter. And what does low pass filter do? So it will create a threshold below which it will allow the signals, above which it will cut off the signals. So if you feel your noise is of high frequency, then you can apply a low pass filter where the high frequency noises will be cut off and eliminated, and only the low frequency important information will be passing on. And the next type of filter we have is the opposite, high pass filter. So high pass filter is the opposite of low pass, where any signals above the threshold will be allowed and below the threshold will be cut off or eliminated. So if you feel your noise is low frequency, then you have to apply a high pass filter. So how will I know whether it is low frequency or high frequency? Simple thing, visualize it. So you have to just plot the signals and you can understand. If majority of the data is present in one band, in the lower or upper, then you'll understand that is the data, because noise is not going to be present 100 times, 100% of all the time. So it is going to be present only a few times. So in that case, you will be looking for the portion where majority of the data is present. That is what you call as the normal or important information. And the others is the noise that we need to eliminate. So that's where we'll be going for these kind of filters. And once the third filter we have is the combination, where we call it as band pass filter. So it's a combination of both high pass and low pass. So where it will be allowing within a particular interval. So more than the lower interval and higher, less than the higher interval. So those frequencies will be accepted. And finally, we will be having band stop filter. So which will be stopping in between a ray intervals, and others it will be accepting. So one of the steps that we do in pre-processing is filtering, and the next we will be doing is amplification, because the signals that we get from inside our body, whether it's a chest or the cardiac or even the brain, so that would be in mu amperes, so microamperes or milliamperes. So that would not be that much sufficient. So you can go for amplification and you try to increase. So this sometimes will be taken care by the hardware also. If not, we can do in software also. There are some programming techniques which we can do. And after that, we will be going for the thing. Sorry, not here. So here. So once we have cleaned the signal, now we will go for our analysis. And one of the most important things you guys will be doing is transformation techniques, because this analysis will be happening in three different time domain, and second is frequency domain, and the third is both time and frequency. So both time and frequency. So where you will be combining both. So in time, what we'll be doing, we will be trying to extract features. So basically in this section, we will be trying to extract features from it. So because when I look at the waveform, I will not be able to understand what is happening. I need to extract some important features, right? So what I'll be doing in time domain, the important features is the time period, obviously. So what is the total duration of the signal? If it is for a longer period, then you might understand there is some abnormality or there is some other thing that is going on. And the very first, another thing you will be doing is amplitude, because you need to understand what is the strength of the signal. So if the heart is not pumping, or if the electrical system, if the SA node or the AV node is not performing properly, then it won't beat up well, and the electrical signals will be less in amplitude. So you can understand these things. So these are some of the features that you will be extracting from the time domain. And for to frequency domain, that is where we will be going for this transformation techniques, because we need to apply some techniques to change the signal from time domain to frequency domain. So you have Laplace, and then you have Fourier, and then you have Z transform. So Z is a discrete transform, but still these are some transformation techniques you can use. And once you finally extract the features, you can understand. So this is how a typical signal processing project involves. So you take a hardware component, ECG, EEG, whatever it is, extract the the signal from it, filter the data, because you have to remove the noise. And once the signal is clean, then you go for feature extractions in time or frequency domain. So extract the time period, amplitude, bandwidth. In frequency domain, you will be extracting one important feature called as power spectral density. So power spectral density. So these are some of the features that you will be extracting. And from this, you can do your analysis. And yes, obviously, you have one important thing, AI. So if you can't understand what things are doing manually, go for AI. This is the next step to that. So once you start extracting the features, you can provide the features to a machine learning or a deep learning algorithm, which will try to learn from these features, and you can predict some diseases. So for example, let's say I am collecting ECG data from 4 or 5 patients, and I know some patients have had problems and some don't have. So let's say 2 patients are normal and 3 patients are affected with heart disease. So I will be collecting the ECGs separately, 5 ECGs, and I'll be marking them as this two are normal, these three are affected. And after that, I will be doing all this process. I will clean the signal, pre-process the signal, amplify if needed, and then later I will be extracting these features like time period, amplitude. In time domain, we can be doing some statistics based features also, statistics, where you can go for mean, median, mode, then we have variance, standard deviation, and there is a lot of things you can go. So once you start extracting these features, based on this, you can give this data to an ML algorithm, which will be trying to learn and understand the patterns of the features. And based on that, it will try to predict whether the patient has some heart abnormality or not. So this is a kind of a mini project you can start with. AI is a bit of the high end, but before that, you can just start extracting these features, like extracting the power spectral densities of various signals. And this is where you will be, this will be very helpful in EEG, because EEG has bands, right? So there are 4 or 5 different bands in EEG, where you have the alpha band, and then you have the beta. You have the beta band, and then you have the gamma band, and then you have the delta, and then you have theta. So these are the different bands that are present in an EEG. And you can apply this frequency transformation techniques like Laplace or Fourier. And once that is done, you will be able to see all the 5 bands individually. So alpha refers to, I think, normal activity. Beta refers to, like, alpha is extensive activity, beta is normal activity, and deep sleep. Delta is deep sleep. So you can see if signals are appearing in a particular band based on the activity of the patient. So this kind of analysis is what you can go with signal based processing based projects. So this is about signal processing. If you guys have any doubts, I think I have bored a bit. Some people have left also. So because signal processing is a bit of a boring subject, but these are the things or the scope or the different things that you can do in a signal processing based project. Guys, any have any doubts? Anything? Am I boring a lot? Is it a lot? Was I don't see much of doubts also. So any doubts, guys? Any questions? I even asked the question in between what PCG is. So anyone, if you would like to answer. Okay, if not, we'll just move on with the next thing. Yeah. So okay, thank you, Harish. So the next thing we will be looking is image processing. And the same concept only, even though I am just mentioning image processing and signal processing separately, all the things that are going to be is similar to signal processing. So the very first step we'll be doing is filtering, and the thing that we'll be doing is noise removal. So we will be applying different filters, and we will be trying to remove the noise from the image. So there will be gray, salt and pepper noise, speckle noise, poison noise. So there are different techniques that we can use for noise removal. I'll not be talking much because I've already covered them in the previous section. So you can apply these techniques, and once you are done with the filtering, the next step you can go is a whole lot of operations, because it's an image. You can go for different things, and the things that are very important in a biomedical domain. First step, obviously noise removal, because in a real time, if I'm taking an X-ray machine or a CT machine, the images I get would be noisy in nature. So I need to remove the noise from them so that it is showing a meaningful representation of the internal structure. And the second thing I can go for is segmentation. So segmentation is nothing but I'll be trying to highlight out an thing from the entire image. So I'll just show an image. So you can see here. So this is an example of image segmentation. So from the entire image, I'm trying to mark out the man. I'm trying to mark out the trees and all the other things, because it is of. So let's see what is the importance of this task. So if this can be used in tumor segmentation, blood vessel segmentation. So from an entire heart, if you're trying to capture a heart MRI, cardiac MRI, or a cardiac CT, chest CT. So from that you can segment out the different organs. And in if you're considering the heart has four chambers. So you can segment out the four chambers, the arteries, the ventricles. So these kind of things you can segment from that, and you will be able to analyze them better. So this is about segmentation. So in segmentation using image processing, you have binarization techniques. So this is very simple, a simple, clear logic where if the intensity or the value, so image is basically a combination of numbers. So it is a array or a square matrix inside which there are a lot of numbers, and the numbers represent the intensity of the particular pixel. So the pixel ranges, colors are infinite, but we will be restricting them to 0 to 255. So basically 256 shades of gray or color. So there will be numbers from 0 to 255, and basically we will be doing numerical processing. So binarization is nothing but a very basic thresholding technique, where if the intensity is, let's say, 120 is the threshold I'm fixing. Anything less than 120 I make it 0, anything more than 120 I make it as 1. So I'll be converting this grayscale image to a black and white image. So let's say I know that so there is a particular concept in image processing in medical, where you know about cancers, right? Tumors. So tumors are active cells. They will be constantly dividing. They're very active. And in X-ray or CT or MRI, they appear to be brighter in nature. So they are, because they are active, the X-ray and CT interpret them in a way that they appear to be more bright. And this is one of the radiological features that the doctors use to diagnose tumors from medical images. So if you find any bright intensities, then you can understand that there are high chances that might be a tumor. I won't say it is tumor for sure, but there are chances. So you can use this particular logic to develop a binarization technique, where if any the intensities are less than the range, then it is a normal cell. But it is more than the range, then it is a tumor cell. So you can do tumor segmentation just by binarization. So you have Otshu's binarization, so you have a lot of other things. And then the other thing you can go for is region-based methods. So region-based methods where we create a small seed. So we do a region growing, region-based techniques where you find a particular pixel or cell which you feel should be segmented, and you do neighboring interpolation. So let's say I'll take an example itself. So for example, we'll take this example. So let's take this center part of the human. So when you feel it is human, then all the pixels surrounding that will also be assumed to be human. So you just take a small region called a seed, and then you just grow everything around it, and the entire part of the image gets segmented. So this is called region-based segmentation. So there are a lot more things, other algorithms in segmentation. Harish is like, which programming language would be the best to do projects that you have mentioned? So some of the options I would say is MATLAB and Python, but MATLAB is proprietary, meaning it is a paid software, and your colleges would be definitely, some college would be paying or some would be taking the crack version and teaching you. But MATLAB, if you are interested to go in proprietary research, then MATLAB is fine. But I will definitely recommend Python. Python is free, open source. There is a large community. There are lots of libraries, many more libraries than MATLAB that are present in Python. And machine learning, deep learning support is way better in Python as compared to MATLAB. So I would definitely recommend Python for this case. And after this, we'll be going for object detection. So where we'll be trying to detect important objects. So we have detectors like Canny detector, and then we have Sobel, and then we have Previt. So don't worry, guys, that I am saying a lot of terms. I'll be definitely uploading videos covering all these things. Image processing that you need for medical image processing, biomedical imaging. So all these things I'll be dropping a separate video. But as of now, I'm just trying to give you the different tasks that you can do in image processing. And after that, you can go for feature extraction. So in feature extraction, the same statistics, and you have some special techniques also. So first one is stats, obviously, and second one you have HOG, which refers to histogram of gradients, and then you have GLCM, and then you have LBP and all the other things. So I'll not go much into this. And once you're done with this, you can definitely club them with a machine learning algorithm, ML or a DL. So where you will be extracting features from images, and from that you will be doing some classification processes, whatever you want. So these are the different things or ideas that you can go from image processing. And this is what computes most of software, image processing, signal processing, is the majority of applications of software in biomedical. So others can be CAD CAM. So I'm not well versed in that sites, but these are the other things that are present also. So I'll add them also. So finally, we'll be coming to hardware and software. So where we will be, I think we have already spoken this. So basically, we will be using a hardware device to collect the data. And once these ideas you will explain from basics. Yes, definitely, don't worry. So for this image processing, I will be so already for this feature extraction part, I have made a video. So it will be coming up in a few weeks. So I'll be talking about all these techniques and the other techniques. I am preparing content, so I'll be talking about all them in detail with the mathematics, code, and all the other things. Don't worry. So as of now, I'm just giving you ideas on what you can do. So hope that answers. And here, what we will be doing is we will be taking a hardware device to collect the data. And once that is done, we will be providing the data to software. So this software, what it will be doing, it will clean and pre-process. And the second thing what it will be doing is analysis. So analysis includes feature extraction, classification, AI, all the other things. And once that is done, you will be once again sending the results, send results back to hardware. Why? Because you can use that for some kind of alert systems, that kind of thing. So alerts. And if you want to control, so if you want to cut off some walls or all the other things, controlling. So all the other things. So this is a hardware software integrated idea where you can use the hardware to collect the data, send the data to software where it will be doing pre-processing, cleaning, all the other things. And after you get the results and analysis from an AI algorithm, you can send those results back to the hardware and you can use them to generate alerts or to control or to do many more other things. So these are some of the things uh, that we can do in hardware and software based projects. So this is a basic what I would say is a basic ideology. So how you can design projects for software only based projects, hardware only based projects, hardware software clubbed projects. So how can I do? What is the methodology I can follow to design the projects? As of now, I have not mentioned anything in specific. I'm just giving you the ideas how you can develop projects. So let's say you want to do a patient monitoring system. So what you can do, so so you will go with an IoT device. So where you will be collecting a lot of sensors. So body temperature, SpO2, ECG, EEG, all the vitals of the body that you will be recording, and you will be sending them to an Arduino or Raspberry Pi depending upon the complexity. And after that, you will be collecting the data, analyzing the data. So in case of ECG, EEG, we saw the signal processing techniques. You will be applying the filters to eliminate the noise, and after that, you will be extracting features, and you will be finding some issues or abnormalities in the data. And once you find, then you send the results back to the Arduino or Raspberry Pi, and it will trigger an alert. saying that the particular patient has this particular problem, or the SpO2 is going less, or the BP is spiking high. So we can go for complex AI algorithms or very simple threshold conditions. So BP should be in the range, if the systolic you're taking, it should be in 140. So if it is going beyond 150 or 160, then write a simple if else condition. And the diastolic pressure should be more than 90. So if it is dropping, sorry, should be in the range of 90. So if it is going more than 90, or if it is going less than 60, so you can go for tachycardic, bradycardic analysis. So there are a lot of things you can do. With simple if else rules, you can start developing the software part. And once you find comfortable and you get a large amount of data, then you can collect them, annotate them, and you can develop machine learning algorithms. That will be a proper hardware software mixed projects. So this is what I wanted to talk about in this session. So I just created this mind map. It's not that much proper, but still the things I wanted to talk. I'll share this link also. I'll just download this mind map and I'll be sharing it in the description later once this is done. So if you guys have any doubts regarding this, so this is the first thing I wanted to talk about. What projects you can do basically. So this is based on my expertise. Like this is the things that I have analyzed. Apart from that, you can definitely go for modeling. So you can go for in Blender software. So maybe I'll write that also here. Okay, and mode. Yeah. So you can go for physiological modeling. So you can yeah, just yeah. So where you can use tools like Blender. So Blender is a tool where you can do 3D rendering. So you can take measurements from a real man, so or a device or a patient, and you can just incorporate those measurements and develop a 3D model out of it. And you can do combine them with obviously 3D printing. So this can be very useful in the fee cases of this one, prosthetics and all the rehabilitation engineering, that side where they create the prosthetics, orthotics, all the other things. So you can take measurements from a real-time patient and you can develop a 3D object out of it, render it and make a good design, a good aesthetic, comforting and a good working design. And then you can go for 3D printing where you determine a good metal, PLA material. So there are a lot of biomaterials or polymers that you can use to synthesize or develop this kind of models, and you can just create a real-time orthotic or a prosthetic which can be applied to the patient. So this can also be a very good project idea, which is hardware software integrated, because software part is the Blender or the other tools that will be using to do the 3D design, and the hardware is the 3D printing where you will be sending the design to the hardware and it will be designing for you. So these are also some additional project ideas. Apart from that, there are a lot more, but these are some of the things that I wanted to talk in this live session today. And yes, don't worry, I'll be making a separate video also on this. Like this, from this live itself, I'll be trimming and taking but the different things, and I will post a video on project methodology. So basically, I would like to call this project methodology. So how would you like to design projects? So let's say you want to do project in particular skill in biomedical, but how can I do this? So this, I think this would be very helpful for you guys. And this is what I call as project methodology. This is what I have been suggesting to my juniors, also to my classmates, and this is what I'm showing to you guys also. So you guys have any doubts? You can just put in the chat section. I'll just take a sip of water. Any doubts, guys? So, is it clear? Is it interesting? Is it good? Any things you can just say? Yeah, so these like, okay, thanks. Okay, no mentions. So, anything else? So, are you clear with this? Because this is the major thing I wanted to cover, the project methodology, how you can do. Any doubts, guys? You have any queries? If not, I'll just show some list of projects that I have ready made, and I will show you how we can do. And finally, I will end with the tool that I had shown. I'm already showing that, but I have not revealed it yet. Okay, Harish is like, no doubts. Okay, great. So I still haven't not got the answer for this question. What is PCG? So I asked it a long back. PCG is one of the devices which we can use to get signals, but which part? What is it? It's an important biomedical device. Biomedical engineers should know what PCG is. Okay, fine. So I'll just come to this part. So I'll just share this Word document where I have just made some projects, ideas, not the projects, it's some project ideas, and I will be saying where you can use AI to enhance the project or make some advancements also. So like first IoT projects, the very first project I would recommend is patient monitoring system. So I had already mentioned this. So where you take the heart rate, the temperature, the blood pressure, and then the oxygen saturation levels. So you connect all these sensors to an IoT system. So like Raspberry Pi or Arduino, and then you can uh, no, Siddhi, it's not hard. So I'll wait for a few while if someone says what PCG is and what it is used for. If not, I'll just say what it is. So PMS you can definitely develop. So where you can use these different sensors to collect the data from the patient, and you can send to a software. So where you can clean all the signals, do the pre-processing, and then you can extract features and try to find, or you can do for an alert system. So basic level is the first level of PMS is where you try to connect these different sensors to the hardware device, and you just collect the data and you do a simple if else thresholding logic, and you find if there are any alerts. So you will be just alerting. So you can just connect a speaker, or you can connect an LED, a red or green LED or a speaker. So if you feel any of the signals are going very high or low, it is above the limit of the threshold, then you can trigger an alarm. So it will be beeping, and the nurse or the other person can come and take care of the patient. If not, the red emergency light or something, you can just make it to on. So this is a very base level where you will be using simple if else logic. And add-on is where you will be using AI algorithms. So machine learning algorithms will be trained on such data, and you will be trying to find out if the patient has any abnormalities, any diseases, all the other things. So this is an add-on or an next step you can do in this. So this is about patient monitoring system. Second is a smart pill dispenser. So this is also, these are the projects that are already available, and I'm also trying to provide some add-ons or extensions that you can do so that you bring novelties also in the project. So smart pill dispenser is basically where the doctors will be saying to the patients, right? So for your given condition, you have to take these pills in the morning, these in the afternoon, this before food, this after food. So there are a lot of restrictions and conditions where you need to take the specific medicines at specific intervals. So that is uh, about this particular problem statement, where we can solve this using a smart pill dispenser, where you just put all the pills in the respected locations of the dispenser, and it will automatically dispense based on the time. So this is what you can say. This is, you can just create, integrate a calendar kind of a thing. So you can develop a mobile app and you connect that with the hardware, and the mobile app will be having the calendar alerts, all the other things. So that will be controlling the hardware device, and you can just dispense the pills whenever it's needed. So the basically the patient can just log. So let's say he is getting the particular prescription, and they're saying that you have to take tablet A two times after food in the morning, one in morning and one in night. So based on the log, he can just enter it in the particular app, and it will automatically store and keep track of everything, and it will be dispensing the pills according to the time based on which the user has given. So this you can do. This is the thing that is already present. So what AI add-ons or extensions you can do is a voice assistance or chatbot. So instead of manually typing, you can just add what to say, a voice assistance. So where you can, the patient will be directly speaking. So this will be useful for blind people because they can't see and type, right? So instead they can just talk, and you just convert all the speech to text, and that will be taking care of everything. So this is an add-on or extension you can do. Harish is like, what are the added advantages of getting novelties? So the first thing is, if you do something that is already present, then it's called copy pasting basically. So you have to do something that is different or that is better, and that is called innovation. Because what you do is you take a product, you analyze what issues are there in that, and you work in one particular issue and you bring up a better product. So this is called innovation, and you add novelty to the project. So this will be useful for you also, and if you're looking for research publications, this is very helpful because you can't apply, publish a paper on the same topic or same research you've already done. You have to do something different. And the other thing is you can put in your resume saying that this is the novelty or this is the new factor I have brought. And this can be useful in hackathons also, because this is what hackathons are all about. You have to bring novelties, innovations, and all the other things. So these are the some of the few advantages you get by doing novelties. And even your colleges also will be expecting you to bring novelties. They will not advise you to do the same project once again, because if there is something already present and you're implementing the same, then what's the need of you doing it again, because it's already there, right? So that is about novelty. So next is IoT based prosthetic limb monitoring. So what you can do is, let's say a patient has if I have a novelty, that means I can make a research paper on that. Yes, definitely you can do. Like, you have to look onto other research papers also. So if you are doing a particular project, you have to look for the other researchers who have done the same project, and you have to find out what they have not done, so that you take that as a source of inspiration and you do the project. And then you can publish your paper saying that I have compared this with these people and I have seen that these people have not done this. That's why I've taken this particular aspect, I've worked on this, and this is what I've developed. And you can show it in the research community. So yeah, I was talking about prosthetic limb monitoring, right? So the patients who have just newly received their prosthetic, so they might not be very familiar or well attached to the particular prosthetic. So in some case, it can become loosening, so it can wear out or all the other things, because they might not have much idea. So in that case, you can attach some sensors. So I think they call it as gyrometric sensors. So where you can analyze the acceleration, velocity, angular momentum, all the other things of the lower on the upper proximities, because our hands and legs are the ones that move right in different angles and ranges. So you can attach sensors to analyze this particular thing. And simple first, as usual, an if else logic. So if the angle is going way beyond, then it means the prosthetic has been loosened or it is not in a good shape to use. So you can obviously do a monitoring kind of a thing. So the next step or an extension you can do is add AI, where you collect the data from this and you can train an algorithm, and it will be trying to predict whether the particular prosthetic is in a good condition or not, or if not, what is the issue. So this is what this called as explainable AI. So you can see uh, explainable AI. So explainable AI is a kind of a field in AI where it will try to provide examples or interpretation. So let's say we are collecting this gyrometric or this mechanical sensors, and we are trying to measure different mechanics of the foot or the arm. And based on that sensor, we are developing an ML algorithm, and it is trying to say that this particular limb is not working. But how it is not working, why it is not working. So that is there, right? That is what this explainable AI will be talking about, where you will it will say, so in this particular situation, the angle is 135 degrees, which should be 100 only in the case of normal. So this kind of explanations it will be providing. So these are novelties that you can bring up in the projects. So this will be very useful, right? Because bluntly saying that the prosthetic is not working, instead of that, if I'm giving example saying that the angle is way more than the normal range, or the acceleration it is producing is very less than required. So these are some of the reasons by which I am saying that the prosthetic limb is not working. So if we can provide some additional explanations, then that will be very useful to the user or the doctor or whoever is using it, right? So this is an add-on or an extension of the projects you can do. Next, you have IoT wearable for fall detection. So this can be useful for patients having seizures or having abnormal mental status and all the other things. So the same sensors that we saw about accelerometers, gyroscopes, so angle analysis, acceleration, velocity, momentum, so all the other things you can try to predict. And from that you can collect and you can predict fall from that. And you can extend this to a camera also. So the first level is just using sensors, collecting the sensor electronic data, and from that data you're trying to predict it. The addiction the extension that you can do, or the add-on you can do, is use camera. So visual data from that camera, you're trying to predict whether the person is falling or not. So these are some of the IIT projects that I have taken. There are many more, but some I have taken and I am providing add-ons where you can use AI and all the other systems, so you can develop something of your own and you can extend these projects so that it becomes a better version of itself. You guys have any doubts till now? So this is about IoT, where we saw how different IoT projects can be developed and how we can extend and develop those projects. Any doubts? Are you clear? Are you able to understand? Or am I saying something that is going way above your mind you're not able to understand? If there are some terms that you're not able to understand, you can just mention and I'll just explain them once again. Or if specific project you're interested on, we can talk more on that. So I'll be limiting to the electronics now because the software I'll maybe we can take in a separate session. It's about 1 hour or more I'm talking about this. So we can make a separate session where I'll be talking more on the software projects, what you can do and all the other things. So is that fine? We'll maybe carry forward in the next week or some other time when we get time, we will talk more about this. And yes, I will be posting a video also. Live is kind of better because I can just create immediately and I can just talk more on it. Video means I have to do editing and post all the other works also. You guys have any doubts till now? Or am I boring too much talking more about projects, technical side? Anything, any queries you have? Okay. Okay, fine. So I'll think I'll come to I'll talk about electronics and then I will show the website and I will just finish the live for today. So later we'll go on with image processing, signal processing and all the other things. So electronics first is a portable ECG device. So ECG are the leads. So there are two types of ECGs, right? First is the three lead, basically the four lead because one is ground and the other one is six lead, and the other is combination of four and six, that is 10 lead. So the four lead is nothing but the left hand, the right hand, the left leg, and the right leg, where the right leg is the ground. So this kind of a thing is called a three lead ECG system where you can collect the heart signals, ECG signals. And the six lead is where you have V1, V2, V3, V4, V5, V6. So six leads you specifically attach in the chest. So these kind of things you can develop. So you can take the sensors and that will be collecting the data and you can digitize the signals using a ADC. ADC is referring to analog to digital converter because the systems or the analysis that we'll be using will be expecting signals in discretized format. So these signals are continuous in nature. So we'll be doing sampling to convert these signals to patches. That is called pockets or samples. That's called discretized signals. So that is what we do in digitization also. In digitization, basically it's binary logic, zeros and ones we'll be applying to the signal. So this thing, an additional thing you can do, Bluetooth, you can add internet Wi-Fi facilities and you can just develop a mobile app where you can integrate this and collect all the ECG signals and you can view that in the mobile if needed or in any other device if needed. So you need to have a wired device, right? A USB cable or HDMI cable to connect it to the computer or laptop to store. So instead you can develop a Bluetooth module, integrate that in the hardware and that will be wirelessly transmitting the data through Bluetooth. So this is one thing you can do. And another is a biomedical signal amplifier. So I already mentioned, right? The signals that we get will be in the range of microamperes or milliamperes, which is very less and it cannot be useful for analysis. So you need to amplify, you need to increase the amplitude of the signal to in ranges of volts or megavolts. I'm not sure megavolts, but at least in the range of volts. I mean, so we're talking about current rates, amperes. So 10 power 3, that kind of amperes, kiloamperes. In that range, if you can amplify, then it will be better to analyze and you can go for noise reduction and getting better clarity and all the other things. So this is about a signal amplifier and you can often go for an oscilloscope also, so biomedical signal generator, so to mimic the signals for analysis and studies also. So if you're able to understand what is the frequency of ECG, then by using an LC oscillator or an RC oscillator, though they have Hartley oscillator, Colpit oscillator, so there are a lot of other things, right? So you can design your own oscillators which will try to generate signals that mimic the biological signals. Why? Because in some cases we might not get the patients to collect the data, so ethical reasons, all the other things. So if you know about the signal, the frequency and all the characteristics, you can artificially generate the signals using oscillators and from that you can do your analysis. So this is another electronics project you can go for. And the very common project you have is this one, electronic stethoscope. So stethoscope, we can use that device to listen to the heart sounds, right? So we have four heart sounds, the lub dub and two murmurs. So you can try to hear to the sounds, and obviously an add-on is there to use AI to classify heart murmurs. So the four sounds that are present and the abnormal lung sounds. And this is where I'll be talking about PCG. PCG refers to phonocardiogram. So it is primarily used to measure the lung sounds, I guess. I'm not sure if it is heart or lung, but I'm seeing it primarily being used for lung sounds. And finally, we'll be talking about the smart gloves for physiotherapy, where you can the physiotherapist will be doing the massage or some stretching therapist kind of a thing. When that case, you can develop a glove which will sense the data. So it will be collecting the data also, and you can use that to provide reinforcement based feedback. So you can, let's say the pressure at a particular region is not at required, then you can use some vibrators or pressure sensors to apply more pressure, transducers basically. So this kind of a feedback mechanism can be done. So this can be used for training of the physiotherapist also, and in some cases you can use for monitoring, analysis, and all the other things. So these were the different project ideas that I have as of now. And if I want to stay, I can say a lot more. There are infinite ideas. You just need to think. You just need to think about the equipments that are being used right now, the problem statements that are being used right now, and you need to think on the innovations and other factors. And that is where I was talking about this particular thing, this project methodology mind map. So this is important. You need to understand, or you need to know how to develop a project, so that once you get a problem statement, you can think, innovate, and you can bring upon new ideas which people have not done before, and you can develop your own projects. This is the most important part, and I want you guys to understand this clearly, because I can give you thousands and thousands of ideas. You can, if you go to any project center, they will be giving you a list or catalog or a menu. You will be having hundreds and hundreds of different projects that are already present and that are going to come. But unless or until you're not able to understand this project methodology, how I can design a project of my own, what and all steps are there, what should I do? If you're not able to understand this, then there is no use of me telling hundreds and hundreds of projects. This is the most important thing. And this is the major motive for me to keep this live session today. So I hope you guys understood this part. This is the most important thing I wanted to teach. And if even the three or four people watching, if you guys understood this, I'm happy. This is what I wanted to talk today. Very clear, guys. Just mention in the comments I'm clear. It's good understanding something, because I want you guys to understand this better. This is the most important thing, because once you're clear with this, then you will have an idea on how to design your own project. You won't even need me. You even need your supervisors, your professors to go and ask them for project. Right. This is what majority of the people will be doing. So in final year, you have to do a project. You will go and talk to the professor. You will say, sir, do you have any project idea, ma'am? Do you have any project idea? And they will be trying to give the projects that they have not done, or they have unfinished projects. They'll try to just give it upon you, and sometimes you might like it or you might not like it, and it will be forceful and things won't go great. Instead, if you understand this, you can design your own problem statement and you can convince your professor that I'm going to do in this. So this is how I did my project, because my supervisor had a existing problem statement and he wanted me to work on it. But I instead insisted him and I convinced him to work on my own problem statement, because I understood this very well. And I said that these are all the things. This is my project. This is the problem statement. I want to do these particular steps, and these are the results that I want to bring, and these are the impacts that will be occurring because of this project. And he was also interested and he got convinced, and that is how I did my project. So it is better if you understand this methodology and you design your own project and you can do it on your own. So any doubts, guys? Anything? Anything else? If you have any problem statements you want me to discuss on, if you have any doubts still what I've said, all any things you can tell. I'm not strong on electronics. Once again, I'm saying if you have anything related to software, I can very much help in signal processing, image processing. So my works have been done majority in the image processing domain, especially in AI. So machine learning, deep learning algorithms, the segmentation, object detection. These are some of the things I've worked on. The feature extraction, all the other things. Yeah, don't worry. I remember about the announcement. I'll come back to that. So that's with that, I'll be ending this stream basically. So before that, if you have any doubts, so this announcement is basically I have gone a tool. So right now, till now, what I have done, I have showed what are the different technologies, how you can do projects and all the other things. But what if I say there is a one website, a single website or a single tool which has everything in one place? So when you take a project, you will see the project files, you will see what and all things are done, you will have a blog, you'll have a YouTube video, what and all things you need, everything will be present in one single place, so that you need not go for other places and look for the projects. So that is that kind of a website is what I'm going to show you. It is more on the technical side, technology. So you have web development, app development, machine learning, image processing. So it is more on that side, but still it will be useful for you guys. So Kashyap is like, bro, I am having trouble understanding signal processing. What can I do? So what I would suggest is I would say become strong with maths. And the most important thing is transformations, because signal processing, the majority of the topics present in signal transformation is going to be in the time to frequency transformation. So you have the Fourier transform, Laplace transform. So you have Z transforms. There are a lot many more transforms. You would have studied this in your M2 and M3. So in your second and third semester of, I'm not sure in which semesters, but in the first 4 semesters, you would have learnt about these transformation techniques. So first master them well, understand how a data is being transformed from time to frequency domain. So that is the most important thing present in signal processing. And you will be I think you will be covering about convolutions also. So how the convolution operation happens. I'm not from math background. So do you have signal processing as a subject? Like, are you asking me in academic point of view or from project point of view? If you can say that, it would be better. Because if you're looking from an academic point of view, then I would suggest you to go into the math, understand the signals, understand the transformation techniques, to go into the derivations, convolutions, and all the other things. But if you're wanted to looking from the side of a skill development, then I would suggest you can focus on the programming part. So Python or MATLAB or I think these are the majority things you can do. But I would recommend in case of skill development or projects, you don't need to look much on the math side. You just need to understand what that process is happening. So you can, yeah, I remember this particular tool. So there is another tool called LabVIEW. So LabVIEW is also a graphical programming. So this is a no-code kind of a platform where you can just do a blocks kind of. So this is also from National Instruments. So basically you can see here, right? So you can just make blocks and this will automatically do the circuit for you. You can do signal processing, image processing, AI analysis, all the things you can do from this LabVIEW software itself. So you can just connect all the components. It will be like a plug and play kind of a thing, and you can do the signal processing operations, image processing operations, whatever you want. It will be doing in automated fashion. You need not hard code and do much of the stuff. So I hope this answered your question. So if it is from theoretical academic background, you have to focus more on the math side. You have to start with transformations first, and then you go with the signal processing topics. Then you might get a better understanding. If you're looking from a skill development or project, then I would suggest you to understand the concepts well, and then apply this project methodology which I said, and you can develop projects and get signal processing as a skill. Once you start, later you can study research papers, do the math, and then you can enhance your skills. But to start as a signal processing, I would not recommend to go with the math side, because you will get feared and you will just leave that as such. This is the issue I find in image processing also. People immediately start with the maths, they go with all the transformations, convolution, blah blah blah, and people just get petrified and they get feared that why there is a lot of maths, because lot many people don't like maths. Even like Sijin also, he says, right, he doesn't like maths. So that's the issue. When you start with something very heavy like maths, then people won't love that particular subject. They won't find it interesting. You must start with applications, how things work out, and then gradually go on and increase the maths. Immediately don't go with the math thing. Later on you can go. Well, you to understand the skill and to get a basic level of understanding, math is not required. But if you want to master the skill and you want to enhance yourself, then math would be required. By the time you will be understanding a lot more, and then you yourself will be voluntarily learning math. Because let's say if you're learning AI, initially you need not know about math, but once you have entered into the field and you know a few things, you want to grow yourself more, you want to enhance yourself, then definitely you need to understand and learn math. And that necessity will make you learn by yourself, and you will find it interesting because you obviously know the applications. You know how cool AI is, you know how AI is working, so that will give you a boost or a motivation to learn the math for AI. Um, so we'll wait for a few minutes. Any more doubts? And then I'll show this particular tool and we will end the stream for this week. Anything else, guys? You have any doubts? So, Kashyap, I guess I would have answered your question. If not, you can ask me anything else if you want. I can answer it once again also. Anything else, guys? You have any more queries? Or else I'll just show this particular tool and we can finish the stream for this week. I think Sijin is still traveling. He has not joined in the chat section also. It's fine. Yeah, he just said. But yeah, things do happen. So okay, I feel there is not much of doubts you guys have. So I'll just show this. So this particular website is projectlearn.io. So you can learn by doing. So that is what I said. This is what I was preaching this entire stream. So you have to learn by doing practical experiences. So this is called project-based learning. So PBL that we say. So you can see web development, mobile development, game development, machine learning, all the other things. So when I go inside machine learning, you can see a lot of projects that are already present. So CNN that detects pneumonia from chest X-rays. And then anything else you have regarding to you have hand key point detection. So this can be used for the prosthetic monitoring or all the other things. So this is an image processing based project. Object detection using mask RCN and facial landmark detection, and then people counter. So object tracking, face clustering, saliency detection. So these are some of the basic projects you can learn by doing. So let's say I'm taking this particular thing. So I'll go inside and you can see the description. You have the project link, you have an article also. So when I click article, I think description external link, yeah, so it will redirect to another link where they have made given everything. So you can see that it is all in one link basically. So here they are mentioned in specific. So what is pneumonia, how to detect pneumonia, or what is the approach you are going to do, data collection, and then what are the pre-processing, so normalization, augmentation, and then they're going for the CNN, this is a deep learning algorithm, and they're doing the analysis, and finally they're getting the results. So this is an entire project and all the entire code he has given. So you might not know this blog directly, but this website is helping you because it is collecting all this together. So you can see, and once you have done this, you have finished this project, then you can go for more projects also on this side. So you can see generate an average face, image stitching, break a caption. So let's say we are going for image stitching. So they have another link here. So it's an article. So you can go to the article. So it will be another blog. So it is collecting blogs from different blog websites where they have mentioned the step-to-step tutorial to do a particular project. So this is the tool I wanted to show you. This is more on the software side. If I find any other things related, then you can. So they have mentioned here 36, out of which 5 are videos and 31 are articles. So you can see here also technology. So by Python, I can sort TensorFlow, Keras, Scikit. So Scikit is basically machine learning operations. TensorFlow, Keras are deep learning operations. Python is general, the programming language we use. So you can look for the different projects that are present and you can get all the resources in a single place. Yeah, so you can see video is there here. So when I go to this, I think it will be going to a YouTube video. So in this particular video, you can see recommendation system. So he'll be explaining about the recommendation system, so how we can develop and all the other things from scratch with code and everything. So this is one of the things I wanted to show in this live today, projectlearn.io. So in this, you can look for the various starter projects with all the resources in just one place. So as of now, it's for computer science based, where you have web development, mobile development, game development. But still, you will be using this. Even as biomedical engineers, you need to learn these things because and patient recommendation system, you will be developing apps, right? So you can understand how to build basic apps from these things. So you just need to have a basic idea of app development. That is what you need because your focus is more on integrating the hardware to the app. So how can I send the signals from my Arduino to my mobile application? If you have understood that, that is more enough because there are CS developers who will be developing the apps with front end, back end, database, blah blah, all the other things. But you need to understand the integration. Just for that, you need to understand the basic development because even in my case, I develop algorithms, but I need to publish or I need to deploy the algorithms in a place so that the users can use it. So that just for that case, I have learned basics of web development and app development. So you can learn from basics from these place and you can develop apps or websites and you can integrate them with the hardware to do your hybrid projects. So this was about all the things I wanted to show in this live today. I'll just switch back to my normal. screen. Yes, so that was all I wanted to talk about today's live session. I spoke about many projects in electronics, in IoT. We saw about multisim, we talked about Autodesk Eagle, and then I spoke about signal processing, image processing, all the other things. The project methodology mainly is what I wanted to get. And we saw some basic projects in IoT and electronics and how we can extend the projects also. So if you guys are interested specifically in this, then I will make a separate video where we will be talking about the projects and we will be talking about different ideas where you can extend them and you can make something new out of it. So if you're interested for this, you can just put it in the chat section and I'll be making a video in future. Because videos I have planned a lot. So I don't know how many of you have seen my video on the AI introduction. So that is the first that we have posted this week. And in the upcoming week, I'll be talking about data analytics, data visualization, all the other things. And the next week to that, we will be talking about machine learning. So that's a very important topic, right? So how machine learning works, the different algorithms, all the other things. And coming to that, we will go for image processing and computer vision. So this is the plan I have for the following weeks, and I'll be posting some heavy videos. So it'll be 2 hours, 3 hours, 4 hours kind of videos, and I will be teaching all the theory concepts just in a single go. And after that, I'll be looking for code marathons. So where I will be talking about codes. So how to deploy these algorithms, how to train the algorithms, how to do these techniques, whatever we saw in the theory, how to implement them in practical with codes. I will be teaching all the things and I will be posting the videos. So these are some of the updates that will be coming um, on the channel. Stay tuned and do obviously share the video, guys. It would be great if many people watch these videos because you yourself know how much time I'm dedicating for this particular videos, editing, adding the animations, and these are some things that takes a really lot of time because that's why I prefer live. I can just talk directly and it's very easy for me. But in case of video, I have to do the post after recording sessions. I need to do the editing. I need to design. I need to add more animations and all the other things. And for creating the PPTs, I add a lot of tables, a lot of graphs so that it becomes easy. So it would be great if you guys can share this to your classmates or to your seniors, juniors, whoever you feel these videos can be very great for because I I'll be trying to cover a lot of concepts. Anything about the internships, bro? Okay, the internships that we have said, right? Yes, so the last date is it is 30th of Jan. So I'll be taking this from the month of Feb. So talking about this internship, what we and Shijin are trying to plan is, so we have different streams, like we have digital marketing, social media marketing, and then we have the reel making and animation, and then you have code generation, and you have content creation. So what you guys will be doing is we will be giving you instructions, we will be helping you out. So basically what we are trying to do is we will be generating a lot of content in LinkedIn. So we'll be developing blogs, we will be writing a lot of stuffs and we will be helping you. So I have experience in blog writing. I have had a startup where I have written blogs, published and all. So I'll help you with all the other things. And about reel making animation, Sijin will be helping more graphic designing. And for code generation also, I'll be telling you it is more of learning by doing more than of us teaching you. So you will be doing the tasks and we will be monitoring you and I'll be supervising and we will do all the mentorship and all the other things. So this is about the internship. So there are still 4 or 5 days left when you can apply, and after that only we'll be shortlisting and selecting the interns. So I think we will be selecting maximum of 4 or 5 interns, 1 or 2, max 2 per category, because we might not be able to supervise a lot more. So let's see, based on application. So there are 4 or 5 days left. So keep applying. Only two things I require: resume and introduction video. I know it is a bit hard, but this is what is needed, guys. You need to be confident enough to open the camera and talk for a minute and send us a video. If you're not confident, then how will you survive an interview? So this is very important things, right? That's why we are looking for resume and introduction video. So this is about the internships. Anything else? Okay, so if not anymore, I'll just wait for a few minutes. If not, we'll just wind up this session. And next week, Sijin will be joining back and we will have more chit chat. We'll be talking more about internships. we had left that internship topic in the previous week live, right? So we'll be talking more about internships, all the other things. So I think the previous live was more about the cold calling, cold marketing, and all the other things. So this next time we will talk about internships. You have any doubts, any specific things, we can talk more on that. We can maybe talk about interview preparation because that is a topic which we have not touched till now. We have talked about research. So I have made videos, posted videos on research. Research masterclass is done. Live also is done in research. And internships also we have spoken about. I think one or two lives have been done. And mini projects and projects also we have had a live session today. So I think one topic we have not yet touched is interview preparation. So how to prepare your resume, how to talk in an interview, how to present an interview, what to do, what not to do. So we can maybe talk more things about that. Or if you guys have any specific topics, you can just post it in the group, the WhatsApp community, and we can have a live session on that. So anything else, guys? I just wait for a few minutes. If not, we can just wind this session. I hope you guys enjoyed this session. I hope it was interesting because we were talking about maybe any video about GitHub, bro. Yes, definitely. Don't worry. I will be making a special separate video on tools and other softwares that you need to know. So for basically AI, Python, image processing, signal processing. So I will make a video on this GitHub. Actually, I think I have already posted a video. So there is a video called the Practical Roadmap to Master AI. So you can check it in the channel. So I have made this video where I have talked about LinkedIn, GitHub, Kaggle, Medium, all the other things. So I have already made a basic introduction of GitHub. But if that is not enough, then I will make a separate video about GitHub where I will talk about how to create a repository, how to publish the repository, how to add collaborators and all the basic things, how to create a good profile and all the other things we can talk about. But I would recommend you to watch that video. It's a practical roadmap to master AI or something. So in that topic, I'm not sure we changed the titles also recently. So it is in that particular video. I've spoken about all these things, how you can practice and master AI, what cycle you can follow so that you and your resume also develops. Any more queries? We just wait for a few minutes. If not, we can just finish. Okay, I feel there are not any more queries. So I hope you guys enjoyed this session. Like we spoke a lot about the project methodology, image processing, signal processing, IoT, electronics. We saw some sample project ideas and how we can extend them also. I showed a few websites where you can start upskilling yourself and developing, and we saw about projectlearn.io also at the end. Do share this live to your friends. If some of the people have missed it, then this is definitely recorded and present in YouTube. You can just share this link to your friends, colleagues, classmates, seniors, juniors, and if any of you are watching and have not yet subscribed to Biomed Bros, do subscribe. Do hit the subscribe button. And if you have any other ideas or any queries or any feedback, you can definitely join the WhatsApp community. The link is there in the description, and we will be more than happy to help if you about your queries. And regarding the internship that we are going to offer, it is available till 13th or 30th of Jan. So 4 days are more left. You can apply, and after that we'll be shortlisting and we will be providing the offer letters, and you can start working your intern as long as you want. So this is not a fixed time period. We will be mentoring you as long as you want. So if we mentor you for maybe 2 or 3 months, you will learn the skill and you can even become a moderator of the channel and you can take part of things also. So these are some of the things I wanted to say, and all the best for the upcoming week. It's the last week of Jan, so if you have any exams or anything's coming up, so all the best for all the things. Take care, stay safe, and signing off, Saramaitya. Bye bye.